Okay, let's have a quick overview of FFmpeg Unity Bind 2 package. And here you can see a demo scene assembled for easy understanding and to see all examples. And at the right scrolling panel you can see use cases. For example, first one is a version most simple and minimalistic demo. Always start from very simple and increase complexity of what you are doing by small pieces. In this callback console section you can see exact version of the library and included libraries as well. In the convert use case you can totally transcode video from one format to another, or even to audio or GIF or any other format which you like. We're working under application persistence data directory, and here we have a demo file which is distributed with a package of MP4 format. Let's choose it. We got path of the demo thanks to Gigafile browser package, which is also included as a bonus to current plugin. And we can specify every extension which we want. Just make sure the format is supported by your operation system. In this case we will use Windows Media Video. You can see processing output here, and you can see the progress bar. The result video is opened in a Giga Video Player package, which is also a bonus package included into FFmpeg Unity Bind 2. Okay, let's move on. We can also do the same with a multithreading, so we can convert a lot of videos simultaneously and save time and produce more with the same bound of time in parallel. We can have adjustable amount of copies we want to transcode. We converting all of them from MP4 to Windows Media Video. It can be every possible format, for example MOV for iOS or MP4 for Android, and many more. As you can see, the last video started, the demo file converted 3. We can see this output specifying the path where the file is created, so all results exist here as a files. We had the demo file first, and then just a demo file converted in a sync manner, and then we had 3 more files converted in async manner. So yeah, let's move on. Decode. With the decode use case you can take any file, video file, and disassemble this video file into set of images, frames, sequence, and also audio file if the video have some audio track. We can see frames, current frame processing, and also progress bar as well. Okay, it is done. Let's take a look to the files. We can see our previous files, and also we can see all extracted frames. Why it is important? Because you can import every single image and produce some image processing use Unity texture class or bitmap or any kind of other image processing, and you have audio file as well. And the even more interesting is that in the next use case of the demo, you can do backward operation. Choose directory with images. Demo code will find all these frames and basically pack it back into the memory efficient, quick and lightweight video file. So after you made all your image processing or create either your own frames and video elements, you can encode it back into the file. Okay, let's move on. Let's take a look to record screen demo. If we hit start capturing, it do recording, and when we hit stop capturing, it creates video file. What is important, as you can see, that the 3D objects in the scene, 3 of them of these random objects are rendered, and 2 user interface panels are rendered, but at the result video, let's take a look to this. On result video, you can see that only one object is rendered and only one UI panel is rendered as well. Let's take a look why is that. This is because Unity FFmpegREC component of FFmpeg Unity Bind 2 package allows you to specify the layer which you are rendering. It is specified on the camera itself, so basically the cooling mask is excluding transparent FX layer and including user interface layer. And if you take a look to this panel, it is transparent FX layer, so it is excluded from the video recording process. Same for the 3D objects in the scene, it's transparent FX layer, so we can decide what we record to the video. Okay, let's move on. Let's try YouTube stream demo. We need stream key for this. Let's go to YouTube, hit create at your channel, select go live. We are starting stream right now. YouTube is preparing stream on their backend service. And we need this stream key. Let's copy it and go back to the demo, paste and start capturing. It looks the same with the recording screen demo, but instead of saving it to file only, it also pushes the stream, the video file, to YouTube. And here at our stream section in the web, we can select stream health to monitor status of our streaming. Let's take a look. The FFmpeg library processing video file and starting pushing it to the backend of YouTube, so we can see this green status that it is connected and stream is working. Basically over HTMP protocol we are pushing video data to YouTube backend services, and YouTube render it to the front end of Google Chrome browser in this case. Okay, now we can stop our video stream and move on. Let's give some time to the demo to push everything which is holded in the stack queue to the backend service. Okay, I think it is done, and let's try another use case, which is stream. Let's choose some video file. We can choose any of this, but let's do it with a demo file which we prepared for you to easy test stuff. And in this demo you can select the start time in seconds and duration of the file. The demo file is 30 seconds length, so we can take without any problem 5 seconds from start and 5 seconds duration. Let's execute this and see the result. It's a 5 seconds video starting from the 5 seconds from the beginning. Next demo is compress. Let's select a video file. Putting quality into the minimum should bring us a result similar to some pixel art stuff. I think it's almost nothing visible should be in the video, as you can see, and very abstract and some visual style of digitalization. And let's use some maximum value, and it should produce for us lossless format, so the quality is maximum. Producing time is bigger, but the quality is very high as well. Let's take a look to the result. As you can see, the quality is very high. Okay, let's move on. Append fast and append full. So if you're sure about the codec of the video, for example, your application produce only MP4 files, so you can use append fast to create one single video file from several elements. For example, we choose this directory. Code of the demo will find in the specified directory all files of chosen extension, and try to create a single file from all of them. As we can see, it was super fast operation, append fast, because of same video codec. There's also possible situation when all video elements are of different codecs, so in this case you should use append full. It will transcode every element and create reliable final video clip from all these elements. And this operation will be a little bit longer, but it is safe to use. The only condition you should always follow is that all video elements should be of same resolution. You can change resolution with other FFmpeg library command, or add some change in resolution to existing appending command. Our demo video file is without any sound. Let's put some track on top of it. we have add sound fast and add sound full options. The rules are same as previous, so if you have video file and audio file which are compatible, in this case it is demo file mp4 and audio file sound.aac. These codecs are compatible and we can use add sound fast. Otherwise, please use add sound full to totally re-encode it. Execute. Super fast operation. And we have some song added to this video clip. Okay, great. Let's take a look to adding watermark. This demo shows you how to bring any kind of image on top of the video. Using the demo file, we choose some image. Let's not use frame because we won't see any difference. Let's use this icon. Choose. We can specify and adjust image scale, image position, and execute. The progress bar is here. Okay, and we have this icon from the file. Put it directly to the right top corner of the video. Not hesitate to experiment with your custom FFmpeg library commands. You can do it here in the direct input demo. This is a sandbox to try on and figure out which command is used the best for you. Let's try to transform one of our result videos, for example this example with audio. Let's transform it to, we copy path of this file and put it here and specify output path, change extension to mp3, and this command should create audio file, extract the sound from our video, and as we can see, here is the audio file with the same name as the original video. And now let's try to build something with FFmpeg Unity Bind 2. We already talked about different resolution for elements in Concat demo. So let's create a functionality which allows us resize video file. For this purpose I created the app directory, main scene, and also two scripts, FFmpeg resize command and FFmpeg processor. FFmpeg processor is derived from monobehavior and attached to this new game object. Also I created event system which is necessary for gigafile browser to allow us pick input file. Okay. For inspiration to the command we can use Google FFmpeg most useful commands, pick some article and choose some command like this. Okay, resizing video, right? Let's open FFmpeg resize command. So we are creating object model wrapping the FFmpeg API. Okay, let's overwrite string method and make command like this, right? Let's derive from base command, which already has some handy stuff for all next commands. Let's generate constructor. Okay, fine. For this command we have input pass, output pass, which is this and this. Also we need resolution arguments, so let's add them to the constructor. Resolution. Okay. Okay, great. Now we can create some command here. Once we have all needed arguments. The first one is FFmpeg. We don't need it just because we are already inside the application which contains FFmpeg. We're already inside FFmpeg basically. The first one is input command argument. So let's add some cool stuff from FFmpeg Unity Bind 2. Instructions. Okay, it already have all needed instructions. If you take this, we can see that this is the input instruction. This means the next will go the input path of the file. Please also use documentation of FFmpeg library itself. Let's use some tools to get path quickly. Okay, next will be resolution instruction. We have it as well for you. Okay, next let's do it like this, beautify it a little bit. Next will be resolution width per resolution height. Okay, let's use copy codec instruction. And next, copy instruction from here. Copy instruction, right? And the last one, output path. Okay, we created our command, and let's debug this command is in start method of FFmpeg process script which we just created earlier. Okay, string command. As you remember, in the final part we should bring an FFmpeg command in form of usual string, and also you have documentation which should be provided in description as a link, so you can see that all you need to do is use this execute methods, which is similar to execution of command line tools. And here is the explanation about the command which we just created. And also, if you want, you can subscribe to FFmpeg events by passing it implementation of this interface as an argument to execute method. But in this demo we will use console to view the debug from FFmpeg events. By default, if you not change print log parameter, everything will be printed to the console log. So let's continue. Let's debug our command. First we created new FFmpeg resize command and put for now some pass as input and some pass as output, and let's specify some resolution, for example HD, good for YouTube, for example. Okay, we have command string right now, and let's print it, just print it to the console log and see does it correspond to command which we want to use. No FFmpeg, right? Correct. Input instruction, input path, which will we obtain from Giga file browser. We will do it right now. And also resolution command, resolution itself arguments, copy audio codec, copy codec, and output path. Okay, looks correct. And let's get output and input path, right? For this we can use FFmpeg, not FFmpeg but Giga file browser. Choose file, right? And we should provide some callback method here. So we move our functionality to callback method once we have input path, right? Not console but on get input path, and as argument we should get input path of the video, right? Put it here as an argument, this callback, move functionality to the callback, and here we already have input path, right? And what we need to do, we need also build output path. So let's do it. String directory, we will take directory from input path. Actually we need this API, get directory input path, right? And then we will take file name without extension, input path, and we will get this one, extension itself, pass get extension in input path, right? Okay, we have all components. Let's build output path. Let's combine directory and let's do like this, file name resized suffix and then add extension Okay, we have output path right now. Let's debug our command again. We will get Gigafile browser user interface opened, and we can choose some file, our demo file. The skin is default without any presets of color scheme. Okay, and now our command looks correct with actual input path and actual output path, right? All we need to do, execute it with all power of FFmpeg Unity Bind tool. Okay, let's do it. FFmpeg library wrapper, and we are doing execute command. That's it. Let's see what happened. Gigafile browser suggests to select file for us. Once we pick file, the process is starting immediately, and we can review the log, and the final stage is on success event from callbacks listener. Okay, let's go to the working directory. This is the original file. It is 17 megabyte size and resolution full HD. And here is our demo file resized. It is, let's see, 2 megabytes, right? And that's HD resolution and still good quality. So yeah, in the demo you can expect code like this. Quality of code is clean, easy to start, and build whatever you can imagine. So thank you very much for watching this, and good luck with your project. Sincerely yours, Giga Neo. Bye bye.